All right. Good afternoon, guys. My name is uh Widin Wali, so popularly called Dr. Nefon. So today, I'll be taking you guys with motion. So because one of the important topic and the best topic in your UTME that the probability of it coming out is very high is what is the wave motion. So I'll be taking us the aspect that UTME usually what ask question from. So just follow me. Now, so wave motion, wave motion. Now, so as I said earlier, I said what this topic is a very important topic for Jambites. You have to know it. So if you don't know this topic and you enter your exam hall, it's very dangerous. Now, so let's continue. Wave motion. What is definition of wave? What is wave? The first, what is wave? What is wave? Now, a wave can be defined as a disturbance. A wave can be defined as a disturbance traveling from one point to another, transmitting a what? Is a disturbance that travels from one medium to another, right? That's the first key point that you have to know about wave. Is a disturbance that travels from one point to another. Now, transferring energy. Do you get it now? So transferring energy from that particular point to another point without causing the permanent displacement of the medium. Again, I said the word wave is a disturbance that travels from one point to another point transferring energy from the point to the other point without causing the what? Without causing the permanent permanent displacements of the medium. Now you can see. Now when you are dividing a particular definition, there are some key points that you have to include in your definition. For example, now I said it was is a wave is a disturbance that travels from one point to another point, transferring energy from the point to the other point without what causing the permanent displacement of what of the medium. So that's the definition of the wave. But Jam can now ask you that the energy that we are transferring is what type of energy? Now the energy that is transferred in the wave is in form of kinetic energy. Do you get it now? So the energy is in form of kinetic kinetic energy. That is, I can define it again as what? A wave is a disturbance that travels from one point to another point, transferring energy from the point to the other points in form of kinetic energy. Do you get it now? That is, a wave is a disturbance that travels from one point to another point, transferring energy in terms of what? Of kinetic energy. Do you get it now? So from the point to that particular point without causing the permanent displacement of the medium. So please, you have to note the kind of energy that is being transferred in the wave. That is kinetic energy. And when we are talking about kinetic energy is the energy possessed by the moving body, and it is type of is the forms of mechanical energy. Do not forget that mechanical energy is a type of energy, right? And it is now divided into two. We have the potential energy and we have the kinetic energy. Potential energy is the energy possessed by the body at rest. When the body does not move, it has rest. Now the type of energy it possesses is called potential energy. While the type of the energy possessed by the body when is in motion is called kinetic energy. So definitely the energy being transferred during wave is what is your kinetic energy. Now, so let's take this example. Let's take this example. For example now. So jump and ask you. Look at this question. Look at this question very well. Now, the energy that is transferred during wave motion is in form of dash. Is in form of dash. A, potential energy. B, chemical energy. C, kinetic energy. And D, heat energy. Now, this is your number one question. Assuming this is your number one question. Now, the energy that is transferred during wave motion is in form of dash. Look at that question. It's always a typical what you tell me question. Even you tell me can definitely add that question. Now, the energy that is transferred during wave motion is in form of dash. A, we have what? Potential energy. B, we have what? Chemical energy. C, we have what? Kinetic energy. And D, we have heat energy. Now, this is very, very wrong. I told you, this is very, very wrong. Heat energy is very wrong. What the answer is what? Is option C. That is, the energy that is transferred during wave motion is our kinetic energy. I hope we are getting what I'm saying and you are following me. Now, so let's continue. What are now the types, or let's say the forms of what? What are the forms of wave that we have? What are the forms of wave that we have? Number one, we have the forms of wave. Forms of wave that we have. Number one, we have what? We have mechanical wave. Mechanical wave. Number two, we have electromagnetic wave. We have mechanical wave. We have electromagnetic wave. We have progressive wave. Progressive wave. Now, you can see the forms of wave that we have. Number one is what? Mechanical wave. Number two is what? Electromagnetic wave. We have what? Progressive wave. And number four, we have stationary wave. Now, so in your secondary school, you learn that okay, the type of wave that we have is mechanical wave and electromagnetic wave. No, that is not like that. So in secondary school, they will say that we have two type of waves, mechanical and the electromagnetic wave. Now, even your jam self know that these are the forms of the wave that we have. Number one, we have what? Mechanical wave. Number two, we have what? Electromagnetic wave. Number three, we have what? We have progressive wave, and we have what? Stationary wave. Now, let's continue. Now, what do you call mechanical wave? What do you call mechanical wave? Now, mechanical wave is a type of wave. Again, Mechanical wave is a type of wave that requires material medium for their propagation. Again, what's mechanical wave? Mechanical waves, mechanical wave is what? The type of wave that requires what? Material medium for what? For their propagation. Did you get it now? So mechanical what? Mechanical wave. Mechanical wave is the type of wave that requires what? Material medium for what? For their propagation. It's called what? It's called mechanical wave. Are we there? Now, mechanical wave is a type of wave that requires material medium for their propagation. You see, anytime you hear propagation in physics, now propagation definitely means what? Vibration too. Now in some textbook, you can be defining your mechanical wave as what? The type of wave that requires what? Material medium for their vibration. Do you get now? For their vibration or propagation, anyone you say is very, very correct. So that's called mechanical what? Mechanical wave. Now, our mechanical wave is now divided into two. Mechanical wave is now into how many? Into two. Don't forget, mechanical wave is what? Is now divided into two. That is, mechanical wave is also now divided into two. Mechanical wave is divided into two. We have what? We have longitudinal wave, and we have the transverse wave. Longitudinal wave and the transverse wave. Our mechanical wave is now divided into two. We have what? Longitudinal wave and the transverse wave. Now, so what is the longitudinal wave and what is the transverse wave? Again, what is the longitudinal wave and what is the transverse wave? Now, let's talk about the longitudinal wave first. Longitudinal wave. Longitudinal wave. Let's talk about longitudinal wave first. Now, longitudinal wave is a type of what? Of mechanical wave, in which the directions of the medium, in which the wave that we are talking about. The type, again, let me define it again. Now, longitudinal wave is a type of wave, a type of mechanical wave that travels parallel to the direction of the medium. Again, is a type of of mechanical wave that travels parallel to the to the direction of of the medium. That travels parallel to the direction of the medium. No, I said this earlier that there are some key points that you have to know. Do you get now? So when you are defining some particular definition, so there are some key points that you have to put, that even if you don't put it, you are wrong. Now, I said mechanical wave is divided into two, which are the longitudinal and the transverse wave. Now, what is now the longitudinal wave? Longitudinal wave is a type of mechanical wave that travels parallel to the direction of the medium. Now, John will definitely ask you, the type of wave that travels parallel to the direction of the medium is called longitudinal wave. And a good example of longitudinal wave is the sound wave. What I call it? Sound wave is a good example of longitudinal wave. Sound wave is example of longitudinal wave. Sound wave is a good example of what? Of longitudinal wave. That's the first one. The next, another example of longitudinal wave is what? Wave in a spring. Wave in a spring. Wave in a spring. You can see again. Wave in a spring. Wave in a spring is different from wave in a string. Wave in a spring is what? Is different from what? Wave in what? Wave in a what? In a string. Now, so wave in a spring is a good example of longitudinal wave. And what are now the what? What are now the what? The properties or the characteristic of longitudinal wave? What are the properties and the what? And the characteristics of longitudinal wave? Now let's talk about the characteristic of longitudinal wave. Number one, they travel parallel to the what? To the direction of the medium. Number two, they do not travel through a vacuum. They do not travel through a vacuum. They do not travel through a vacuum. E.g., sound wave. Sound wave. Please note all what I'm giving you since morning. Please note them very, very well. Now, which type of wave cannot travel through a vacuum? Longitudinal wave cannot travel through a vacuum. Example of longitudinal wave is our sound wave. Sound wave can never travel through a vacuum. So number one is what? They travel parallel to the direction of the medium. They do not travel through a vacuum. Very, very important. Very, very important. Now, and what are the things that we have to know about the longitudinal wave? Yes, and the number three. Yes, number three. Number three is what? Number three, they cannot undergo polarization. They cannot undergo polarization. You see, all these things are what are written in questions. Now, the wave, notes all waves can undergo reflection. All waves can undergo refraction. All waves can undergo diffractions. Do you get it now? But all waves cannot undergo polarization. So an example of wave that cannot undergo polarization is a longitudinal wave. And a good example of longitudinal wave is our sound wave. So sound wave cannot travel through a vacuum. Sound wave cannot undergo polarization. That is, it cannot reflect light. Do you get it now? So it cannot be what? Plane polarized. Do you get it now? So sound wave cannot do all those things. All these things are what? Are UTME questions. So please note all of them. Note them very, very well. Now, so let's continue. Now, under this longitudinal wave, now we now have 2 points on longitudinal wave. Points on longitudinal wave. There are 2 points on longitudinal wave. Points on longitudinal wave. Points on longitudinal wave. So all these things they will not give in your secondary school, do you know? Now they just give you notes. But this one is very, very what? very understandable, right? So you can see I'm make sure I'm breaking everything down for you guys. Now note down that there are 2 points on longitudinal wave. Now the first point on longitudinal wave is called compression. Compression. And we have refraction. We have compression and we have refractions. The 2 points on longitudinal wave are what? There are two. We have 2 points on longitudinal wave. Number one is what? We have compression. Number two is what? We have what? Refraction. Are we there? Compression and refraction. Now, what's compression? Compression, let me write. Compression is a point of maximum pressure in a longitudinal wave. So it means that if I compress something, it's going to exert more pressure. That's it. It's going to have what? Maximum pressure. So you actually compress something together, there won't be what? There won't be space between those molecules. For example, now the molecule of gas, you compress them together. Don't forget that the what? They are easily compressible. Yes, gaseous particles are easily compressible. While solid, they are not compressible. Do you get now? So they are easily compressible for the gas. So definitely the space between gases is very what? Very like close. They are very close to one another. Sorry, the if you compare them together, if you compare the gases together, so what happens is that the exact more pressure. Look at now. So they are the higher the compression, they are the pressure. So that's why compression is a region or a point in a longitudinal wave that have maximum They have maximum pressure. Do you get it now? So that's called compression. Now, but what do we call refraction? Refraction is a region or a point on a longitudinal wave with a minimum pressure. So you can see now. So a point where there is a minimum pressure and it is now located in the longitudinal wave is called refraction. But the one of high pressure or maximum pressure is what is called compression. When you compress something, it will exert more pressure. When it's now moved from the state of compression, it's called refraction, right? Now that one will definitely have low pressure or minimum pressure. So a point on a longitudinal wave that has less or small pressure is called refraction, while the one that has more pressure or maximum pressure is called compression. But note that both compression and refraction are found or they are located on the longitudinal wave. Now, so let's note something here. Note that the distance between two compression to compression is equal to, note it down, compression to compression is equal to 1 over, that's 1 lambda. Note it down, 1 lambda. Compression to compression is 1 lambda. Compression to compression is what? Is no, when we are talking about antinode node. No, okay, sorry, 1/2 lambda. Sorry, it's not one lambda. Now, this C represents what? Represents compression. Now, compression to compression is called to what? 1/2 lambda. And what's the lambda? Is our wavelength. I will explain them under terms using word wave. Now, compression to compression. Anytime you hear something compression to compression is equal to what? 1/2 lambda. Are we there? So 1/2 lambda. Also, refraction to refraction, like two adjacent refraction is also equal to what? 1/2 lambda. So two adjacent compression is also equal to what? 1/2 lambda. Also, but if I have what? Compression to refraction, that one will give you what? 1/4 lambda. Compression to refraction will give what? 1/4 lambda. Also, refraction to compression will also give you what? 1/4 lambda. So please note all these things. JAMB usually asks these questions. So there's sometimes that they will even mention what? Note and antinote. I'm going to explain that one. I'm going to explain it very, very soon now. So C is compression. Compression to compression is equal to what? 1/2 lambda. Now, refraction to refraction is also equal to what? 1/2 lambda. And what's our lambda? Lambda is wavelength. So, but compression to refraction is also equal to what? 1/4 lambda. That is 1/4 wavelength. Also, refraction to compression is also equal to what? 1/4 lambda. So I hope we are getting that. Now, we have what? We've talked about the points that we found on what? On the longitudinal wave. Now let's talk about the transverse wave. 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 Transverse wave. Transverse wave. Now, transverse wave. Now, it's a type of wave. No, don't forget that transverse wave is also a type of mechanical wave. No, I feel that mechanical wave is divided into two. We have the longitudinal wave, and we have the transverse wave. There are two types of mechanical wave: transverse and the longitudinal. Now I've explained the longitudinal. Now let's go to the transverse wave. Now, transverse wave is a type of mechanical wave. The type of mechanical wave that travels perpendicular. To the what? To the direction of the medium. That travels perpendicular to the direction of what? Of the medium. Now you can see that the other one, which is what? Longitudinal wave, I said is a type of mechanical wave that travels parallel to the direction of the medium. But for this one, it travels what? It travels perpendicular. At least it travels right angle. Do you get it now? Angle 90 degrees, right? It travels what? Perpendicular to the direction of the medium, not parallel this time around. Do you get it now? So, and a good example of transverse wave is what? A good example of transverse wave is water wave. Water wave is a transverse wave. Again, water wave is a transverse wave, and wave in string. Wave in a string. Wave in a string. Wave in a string. Don't forget that wave in a spring. Wave in a spring is longitudinal, while wave in a string is what? Is our transverse. Again, wave in a spring is longitudinal, while wave in a string is our transverse. Do you get what I'm saying now? Now, having known the type of transverse wave that we have, what are the properties? What are the properties of transverse wave? What are the properties of transverse wave? The properties of transverse wave. What are the properties of transverse wave? Number one, they travel perpendicular to the direction of the medium. Number two, they travel through a vacuum. They travel through a vacuum. And number three, they undergo polarization. You can see now. So the three properties of transverse wave is what? Number one, they travels what? Perpendicular to the what? To the direction of the medium. Number two, they travels through a vacuum. Do not forget that longitudinal wave cannot travel through a vacuum. If they ask you what can we use to differentiate or to distinguish between what? Between longitudinal wave and transverse wave is that transverse wave can what? Can pass through a vacuum, while longitudinal wave cannot pass through a vacuum. Do you get it now? And the last one is what? They undergo polarization. Transverse wave can undergo polarization, while longitudinal wave cannot undergo polarization. Hope you get what I'm saying now. Now, an example of what? Example of transverse wave is what? Is our what? Is our example of transverse wave is what? Is water wave. Do you get now? Is a what? Example of transverse wave is what? Is a water what? Water wave. Do you get what I'm saying now? And note something here. Note something here. Note something here. Note something here. Please, very, very important. Note something here. Note something here. All electromagnetic wave are transverse, but not all transverse wave are electromagnetic wave. You don't understand that what I said here? Now that means electromagnetic wave are transverse wave, but transverse wave they are not electromagnetic wave. Do you get what I'm saying now? So transverse wave are not electromagnetic wave, but electromagnetic wave are transverse wave. Hope I get what I'm saying now. Do you get what I'm saying now? And if you look at the example of electromagnetic wave, they are electromagnetic radiations. So which we are going to talk about when we get to electromagnetic wave on its own. You get it now. Also, I said what? Electromagnetic wave are transverse, but transverse wave are not electromagnetic wave. I hope we are getting that. So that means water wave is not electromagnetic wave. Is that taken now? So let's quickly talk about the points on a transverse wave. The points on a transverse wave. Don't forget that we have points on the longitudinal wave, with our compression and refractions. So the points on a transverse wave are two. Number one, we have the crest and we have the trough. We have the crest and we have the trough. Do you get it now? So that means crest and trough are found on the transverse wave, while compression and refraction are found on the longitudinal wave. Now, what is crest? Crest is a maximum point. It was a maximum upward displacement the crest can be defined as the maximum upward displacement. Or let me just say crest is a maximum point in a what? The maximum upward displacement, maximum upward points in a what? In a transverse wave. I get now. Why trough? Trough is a maximum downward points in a what? In a transverse wave. In a transverse wave. In a transverse wave. You can see. I said what? I said crest. The maximum upward points in a transverse wave is called crest. Why what? Why trough is a maximum downward point in a transverse wave. So crest and trough are what? Are located in what? In the transverse wave, while compression and refraction are for the what? For the what? For the longitudinal wave. Now, what the next thing that we have to know? The next thing to know is another thing here. Note down, note this thing, that crest, adjacent crest is also what? 1/2 lambda. Do you get it now? Trough to trough, adjacent trough is also what? 1/2 lambda. Do you get? Now, crest to trough is 1/4 lambda. Trough to crest is also equal to what? 1/4 lambda. Do you get it now? So, and another thing is that note that this one, no, I'm talking about the transverse wave. I'm talking about crest to crest. For the other one is compression. They are just CC. You get? Now this one is trough, crest to trough to crest. So whenever you hear something like the distance between adjacent compression or adjacent crest, you're supposed to know that what? Crest to crest must give us what? 1/2 lambda. Trough to trough must give us what? 1/2 lambda. Crest to trough must give us 1/4 lambda, and trough to crest must give us what? Must also give us what? 1/4 what? 1/4 lambda. Are we there? But note something here now. Note that very, very important. Note that now. So crest in transverse wave. Crest in transverse wave is equal to compression in what? In longitudinal wave. In longitudinal wave. Are we there? Now, crest in transverse wave is what? Is equal to what? Is equal to what? Compression in what? In longitudinal wave. Also, that means what? Trough in transverse wave is also equal to what? Refraction in what? In longitudinal wave. So crest in transverse wave is equal to what? To compression in what? In longitudinal wave. Now trough in transverse wave is equal to what? Refraction in what? In longitudinal wave. Please note them, very, very important. Now the next thing is what? Is to now draw the diagram. Let me just give you a diagram of what? Of a transverse wave. Let me give you a diagram of a transverse wave. Now let me give you a diagram of what? Of a transverse wave. Diagram of a transverse wave. Now this is it. Now this is a transverse wave. Now this place is what I call the crest. This way I call the what? The trough. This is also called the what? The crest. Now it's called the what? It's called the what? The trough. I get it that. So this is a transverse wave. A transverse wave. So that's transverse wave. Hope we are getting that. So that means now crest to crest, that is from here to here, is half lambda. Do you get it now? So here to here too is half lambda. Is that taken now? But from here, from the crest to the trough here, from here to here now, it will be what? It will be 1 over 4 lambda. I told you. Also, from this crest to this trough is what? Is 1 over 4 lambda. So I already give you that. So crest and trough are found on the transverse wave. Crest and the trough are found on the what? On the transverse wave. Now, so let's quickly talk about the what? The electromagnetic wave. Electromagnetic wave. Electromagnetic wave. Electromagnetic wave. Electromagnetic wave. Now, so what's electromagnetic wave? This is a type of wave that do not requires what? Material medium for their propagation or for their vibrations. It was a type of wave that do not require material medium for their what? For their propagation. It's called electromagnetic wave. It's called electromagnetic wave. Now, what are the examples of electromagnetic wave? Now, note this. What are the examples of electromagnetic wave? Now, a type of wave that do not require material medium for their propagation is called what? It's called electromagnetic wave. Now, what are now the examples of electromagnetic wave? Now, note that electromagnetic radiations are all electromagnetic wave. Now, electromagnetic radiations are all electromagnetic wave. And what are the electromagnetic radiations? Now, electromagnetic radiations are reflux G. I use this mnemonic for it. What? Reflux G. Now, let me write the full meaning. My R is the radio wave. R is the radio wave. I is what? The infrared ray. The V there is the visible light. The U there is what? Is ultraviolet ray. The X there is what? Is X-ray. While the G there is what? The gamma ray. So all of them, they what? They are all electromagnetic wave. And what are the characteristics of electromagnetic wave? Is that what? They travel through a vacuum. I told you they travel through a vacuum, and whenever they travel through a vacuum, they travel through a vacuum at the same speed of light. I get now. So they travel through a vacuum at the same speed of light, which is called to what? 3 times 10 raised power 8 meter per second. So all of them, radio wave, infrared ray, visible light, ultraviolet ray, X-ray, and gamma ray, they travel with the same speed of light in the vacuum, and they undergo polarization. They can travel through a vacuum at the same speed of light, which is called to what? 3 times 10 raised power 8 meter per second. All these things are example of electromagnetic wave. The radio wave, infrared ray, visible light, ultraviolet ray, X-ray, and gamma ray. Now, let me give you these questions. Let's take these questions. For example, now, let's take this question. UTME. questions. Which of the following wave cannot be plane polarized? Cannot be plane polarized. Number one, we have sound wave. Number two, we have the X-ray. We have the gamma ray. We have the visible light. Now, which of the following cannot be plane polarized? Look at this question. It's a you tell me questions. Now, which of the following cannot be plane polarized? A, sound wave. B, X-ray. C, gamma ray. D, visible light. What the correct answer is what? It's our sound wave. Sound wave is a longitudinal wave. Do you get it now? So it's a, let's just say sound wave is a mechanical wave. Do you know? Sound wave is a mechanical wave because mechanical wave is now divided into two, longitudinal. That means I can say sound wave is what is longitudinal and it's a mechanical wave. Do you get it now? So it's only sound wave here is a mechanical wave. X-ray, gamma ray, visible light, they are all electromagnetic wave. And electromagnetic wave can travel through a vacuum and at the same time they can undergo polarization. But what? But the sound wave cannot undergo polarization and they cannot travel through a vacuum. So those are the two things that can be used to differentiate between sound wave and and other electromagnetic waves. I hope you are getting that. So these are the aspects that you have to know, the theoretical aspect you have to know before moving to the terms used in wave. So my name again is Muideen Waliu, so popularly known as Dr. Nefon. I'm a medical student of University of Ibadan. So this is where I'm going to stop for today. So the next class or the next time we are going to continue on this particular place that we stop. So thank you for subscribing to my YouTube channel.